your computer back?
I did get my computer back. It's so nice. Nice to have it back. Though, see this little blinking light here? I need to restart my computer because when I click the, like now it doesn't bring up the thing, so I have to come up here and click on like what color I want it to be. So it's kind of annoying. And it's like thicker. You can see like it's a, I remember like 3 or 4 years ago I figured out how to make it like really fine tip. That was nice. So it was a groundbreaking day. I remember that day. It's an amazing day. But I just need to restart my computer. Have I done it? No. Will I do it? Maybe. We'll see. Okay. So let's talk about chi-squared. And so yeah, so chi-squared, it's like maybe two multiple choice questions. So we're gonna kind of go through it, talk about what it would be. So it looks like this. Looks like it says x squared, and then it looks like it's spelled out. It looks like it's trying to tell you to say the word chi squared, but it's actually the word chi. So not chi, even though my daughters were born at Chi St. Joseph, you know, Chi St. Joseph. Yeah, C-H-I St. Joseph. So, but when I saw that on the hospital, every time I thought about chi squared. So, you know, I just see the world in statistics. That's what, you know, math teachers do. All I do all day. Go home and teach my daughters statistics.
I'll be so prepared.
Yeah, so prepared. All right, so what was I doing? Chi-squared. It's on the bottom of your formula sheet, actually. Like if you looked at one, there's like confidence intervals, and there's all this other stuff, and then there's a z-score formula, and then right below that it says this, chi-squared equals, the formula has to deal with like how far off your observed values are from your expected value. So like, I thought one of the questions on the review, or not on the review, on the video that I did last week was like, I thought births, like childbirths would be equally throughout the week. Every day should be pretty equal. But I observed Sunday had this many births, Monday had this many, whatever. So you do observed minus expected, and then I want all my values to be positive, so you square that number. Then we want to know how big is that difference to what we expected. So you do observed minus expected squared over the expected, and then it's all these different like Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, whatever, and so I sum all of those together. So this is like your formula. The sum of observed minus expected, square it for positive, divide by expected is what we got. So that is our chi-squared formula. Basically, how well is our data meeting what we expected it to be? And the whole idea, mainly a multiple choice question would be like filling this out correctly and writing it in, or getting the degrees of freedom. So we'll look at that. But this is like a full-on hypothesis test. It's just not one of the main ones we talk about. It could pop up. It's unlikely to be one of the 6 free response questions. So it goes through like a chi-squared table, and you can get a p-value, and you can either have enough evidence or not have enough evidence. Okay, so like the problem we're looking at today is this one with the check your understanding first. On the 11.2 day 1. So on the other video, it was like how do you know to use chi-squared? It's because you don't just have like one thing, you have all these different things being asked at once. Like, let me go back to the whole idea of the Sunday, Monday, Tuesday, ... We were asking how well it fit all of these. Like our other hypothesis tests are like, I thought the proportion of white vehicles on the road was 20%, and I think it's actually less than that. Or I thought the average height of Americans was 5'6". I think it might be different. So that's like our typical hypothesis test. This one is testing like more than one thing at once. It's testing, yeah, two or more variables all at once. Like how well did they fit? So when you have like a table, and like how well does it fit the data? Is this associated? Those are kind of giving away chi-squared tests. Okay, so like what we're doing here is we've got a bunch of males are being asked, would you vote for a woman president? And so 50 of the people are interviewed by a male and asked yes, no, or maybe. And then 50 other males are interviewed by a female and asked and seen did they say yes, no, or maybe. And so these are like our responses. We're testing, is there like a difference in between who's asking the question or not? So if I was to write, maybe I should go back. So if I was to write a null and alternative hypothesis, so it says state the appropriate hypothesis. The null is that I think there is no difference in response based on interviewer. So no difference in response based on interviewer. Like I think status quo. Like I'm gonna go with like there should not be a difference. It shouldn't matter. And then my alternative is that I think there might be a difference. So I think so the alternative is that there is a difference in, and then I'll just do the bunny ears for laziness. Like, same thing. I don't think that's grammatically, okay at all. I wouldn't suggest that, but that's okay. Just, there's no difference or there is a difference is our alternative. Okay, so what we need is we need to compare our observed values to our expected values. Like I expected there to be this many. Like on the Sunday, Monday, Tuesday, on the weekday problem, or whatever it was, like I expected the burst to be equal throughout the days. And so we did 150 divided by 7 to split our expected values. On this one, we need to get a list of this is a list of observed values. I need to get my expected. So how do we get expected values? So this is like part B. Show the calculation for expected. All right, so the way it works, maybe I'll do it. Oh, it doesn't work. I have to go up here and click for a different color. How annoying. Maybe I'll do it in red. I need to get like my expected counts for every single one of these little things here. So the way you do it on this is it has to deal with the total amount of males. Let's say I'm going to do this one right here. How much would I expect for males to say yes? To a male interviewer say yes, I would vote for a female president. So what you do is it has to deal with, what the heck? Has to deal with that total and the yes total. So if I want to get this value, I'm going to do a mixture of the column and the row that deal with this. And what you do is you do the column total times the row total, and then you divide by the total amount of people you surveyed. So divided by 100. So I do 50.
Can you grab me one as well?
Yeah.
50 times 69 over 100. Yeah, everyone, no one's got one.
I'll just pass it.
So for purposes here, when you do 50 times 69 over 100, you get, oh man, I'm gonna have to do my own little, I'm gonna write it in a separate area here, because my pen's too big, that's too small at the table too. When you do that, you get 34.5. When you do 50 times 69 over 100, you get 34.5. So that is this value right here. I expect, based upon how many people were interviewed by a male, and how many people said yes, and how many total people were surveyed, I would have expected 34.5 to say yes to the male interviewer. Okay, so then we also need to get it for every single thing. So I'm also going to do the same thing for the female yes. So it's going to be 50 times 69 over 100. So it's actually the same number, since the same amount of people were interviewed by male and female. So this one's also 34.5. Which kind of makes sense if we're testing the claim that there's no difference. It should make sense that I expect no difference if they're interviewed by a male or female interviewer. So this is my expected. Maybe I'll make a note. Okay, so then let me get a different color going here. So if I want to get these expecteds right here, the males who said no, females who said no, I want to do the total amount of people interviewed by a male times the total amount of people who said no over the total amount of interviewed just in general. So 50 times 11 over 100, which comes out to 5.5 in that instance. And then the female no is actually, because these are both 50, these expected values are actually the same. So it's another 50 times 11 over 100. So 5.5. All right, and then the last one, let's see what this color does. So the 12 there, the maybes, is going to be, again, 50 times 20. So column times row over the total amount. So that's like 1,000 over 100 is 10. So I would have expected 10 maybes. And then again, since it's 50 times 20 over 100, this is another 10. All right, so like, what does a multiple choice question look like for this? These are an example of a multiple choice question. Like, can you tell me, the question could have been, give me the expected amount of people who said yes to a male interviewer. And you would have gotten to choose between a bunch of different multiple choice. And if you correctly put that in, then you would, you would get the right answer, because there's multiple choice, different options, whatever. That's like, sometimes they give you this kind of multiple choice question. Give me the expected amount of people who said maybe to females. So that would be like, the answer is 10. Or give me the formula for it. And so maybe that's your answer. That's like an example of what you would really need to know. So you don't need to know a lot about chi-squared. You just need to be able to nail down specific parts. Here's my expected, and here's my observed. So what we do is I'm going to use my formula, which is observed minus expected squared over expected, and then add all those up together, sum them together. So I'm going to do that for every single response. So there were 6 different options. So like I'm going to do it, let's start at the 30 number. So I'm going to do 30, and then we expected 34.5. So I'm going to do 30 minus 34.5, observed minus expected squared over expected. Writing this all out is another example of a possible multiple choice question. They could have done this, like here's where they try and trick you on the multiple choice. They would have said, instead of this number down here, they would have wrote the number 30. Or instead of squaring it, they wouldn't have squared it. That's they would have given you these different options, and you need to choose the right option. Oops. Okay. So got that. Then we need to plus the next one. So let's say I do the 39. So I observed 39. I expected 34.5. I square it and divide by 34.5. And then you do plus, what was it? We observed 8. We expected 5.5 squared over 5.5. So you just gotta write it all out. So I'm gonna keep doing that. So observed minus expected squared over expected plus observed 12, expected 10 plus observed 8, expected 10 over 10. Alright, so another, again, these are like maybe 2 to 3 to 1 multiple choice questions. This is another possibility, just like writing out the formula, knowing what it actually means to do observed minus expected squared over expected, and getting the numbers. So actually, yeah, so what I'm actually going to do, I need to do one more thing with this. So you get all this, and this is then your like chi-squared value. So this one comes out to, when you plug all of those in, you get 4.25. Is that what you got, Blake?
Yeah, I was hoping I typed it all out before you even said it.
Nice. So chi-squared, 4.25. This is then a value that I could go look up in like a table. So I'll show you the table. It's on your formula sheet. So it's like the very last, it's on the back side of the T table. So ZT, there's the x squared, chi-squared. Okay, so all you need on this is a degrees of freedom. Except the degrees of freedom on this is kind of interesting because there's no like just one column or one row. So what I actually came up with on the second period, I'll show you how to formula do it, and then I'll show you what I did with second period. It was kind of nice. So what you're supposed to do to get the degrees of freedom, so maybe I'll write degrees of freedom, it's supposed to be your number of rows minus 1, so 3 minus 1, times your number of columns minus 1. So 2 times 1 equals 2. degrees of freedom equals 2. Really big, complicated number. What I kind of came up with, I always like to search for random little things that I think might help y'all get it better, is like just cross out any row and cross out any column. So let's say I did this. I crossed out a column and I crossed out a row, and how many values did I have left? Like that's your degrees of freedom. 1, 2. So you could do it that way too. Whichever one works for you. So if you're looking for degrees of freedom is another multiple choice question on chi-squared. So those are like your 3 types of your expected number, your formula, and your degrees of freedom would be what I would expect them to ask you. So you can do it this way, and it's not too hard. Column -1 times row -1. It's easy to forget though. And so if you just forget, just remember to just start crossing stuff out, and then just like count how many are left, and then that might work out for you. Maybe.
You cross anyone out?
Huh?
You cross like
Cross any of them out. Watch, I'll erase it again. Let's cross this one out and this one out. I've got 1, 2. Doesn't matter. Cross this one out and this one out. 1, 2. So literally does not matter which 2 you cross out. You still get 2. Because that's all that's doing. 3 minus 1, 2 minus 1. So that's what it does. Okay, so what did we get? A degrees of freedom of 2.
Yeah.
So then, this is where I'm not as concerned about it, and that's why it's always at the end of the year and we do it in like a week, is if they ask you, I don't expect them to, you would go to your degrees of freedom of 2 and scroll over until you see your chi-squared value. Kind of like the t-table. So 4.25 is somewhere in between 0.15 and 0.10. So 0.12. I don't know. Let's say that. So I would say about 0.12, which is greater than our alpha of 5%. So do we or do we not have evidence for the alternative?
You don't.
We don't. We did not pass the threshold. So you would say no convincing evidence, and then I'll just say this for the alternative. That's not what you should do, but I think we've done it enough that you get the point. So yeah, so that's what you do in that instance. I don't expect this to be a free response problem. Now that probably means it's guaranteed to be one now, but I really don't think it would be. Who knows? Who knows? Okay, but I do expect you then to be able to test you on like that, and I do expect them to tell you, like, can you get an expected number? Like, can you get the expected number of yes to male interviewers? That kind of stuff. Okay, so let's do another one. Let's do the other page, and then on this assignment, you're just doing number 7 and 8, which is gonna get the expected numbers and the chi-squared value. Let's do the taco tongue evil eyebrow example, and then we'll be good. Alright, so I couldn't find that, so I'm just going to draw my own little table here, exactly as it's written on the notes. Okay, so this is like, can you do evil eyebrow and taco tongue? And the question is are they associated or not? So, is there an association? So this is our observed value. So let me go over here and make like my expected values. so what would I expect there to be based upon these numbers observed? So for this one, I need to deal with the total amount of the column and the total amount of the row that actually happened over the total. So 200 times 480 over 600. Which is 160. And then, all right, this other one, 400 times row of 480 over a total of 600. So 200 to 400 is like doubling, so it comes out to a nice 320 is what I expect. So I expect 160, we got 180. I expect 320, we got 300. So we're having, there's little differences. They don't seem major, but that's why we would do the test. Okay, expected on this one would be 200 times 120 over the total of 600. For 40. And then 400 times 120 over 600 comes out to 80. Alright. So this, again, like getting one of these, I would expect that should be like fair game. And then actually doing the formula would be fair game. Doing that. So getting those expected tables, can you tell me what you would expect to get from those? All right, so then let's do the formula. So to get the chi-squared number, I need to do, so maybe I'll just start in the top left. I need to do observed 180 minus expected 160 squared over expected 160. So it's, well, never mind. That's wrong. So that's what I do, plus, what was it, 300 minus 320 squared, 320, plus 20 minus 40 squared over 40, 100 minus 80 squared over 80. Which, before I do that, just let me show you where that's at, since I already had the formula sheet pulled up. So like on the front of the formula sheet, at the very bottom, like that formula is on there, chi-squared, observed minus expected squared over expected. So it is on the formula sheet. Okay, so you end up getting some sort of number. I didn't write it down on my notes. I can just do it in my head again, or if y'all have already typed it in. So it's something like, I might have been wrong in first period. So y'all should probably double check me. But, so yeah, I think we come out to like 1.825 is our chi-squared value. Which hopefully that's right. Maybe. And then the degrees of freedom. What's the degrees of freedom on this? No. So cross. Boom, did it. 2 minus 1 times 2 minus 1 is a weird way to say 1. Like the next time someone today if someone asks you and your response would be, I would like one of those, just tell them I would like 2 minus 1 times 2 minus 1. Just make them mad. Did I get that right? Is it 1.825? Is it a different chi-squared value? Four over 16. Isn't that 1/4? I think that's 1/4. Yeah. I think that's the right value. Maybe.
I got 18.75.
Yeah, that's what I got too.
Oh my gosh.
I didn't want to be wrong alone.
Okay. So I missed some sort of digit somewhere. 40 over 160. Oh, that's why. It's not 40, it's 400. I was missing the hundreds digit on everything. All right, so 18.25. Well, thank you.
0.75.
Jeez. Okay. All right, that's fine. That's fine. Can do mental math. Of course I can. 18.75. Anyways. All right. So main thing, I'm not even gonna like finish the conclusion of like, do we have evidence or not? Because I really don't think it's gonna be something. Could you tell me the correct degrees of freedom, and could you correctly like identify what the formula looks like? When we look at the couple practice exams that we'll do, like I think we'll see what you should be looking for and stuff, and we can adjust from there. But I don't find it very common to like keep going anywhere near there. So I'll just go ahead and stop on that one. Even though in second period we went further. So chi-squared, it's like this whole, how far is our observed from our expected? How much is our difference? And then is that like a crazy big enough difference to say that there's evidence something's weird happening here? So main things are like getting that formula, getting the expected counts is another weird thing. So on this paper, the little assignment, it's just number 7 and number 8. All you have to do on number 7 is get the expected numbers. You don't have to do anything else except give me the expected. And then on number 8, it's doing it all. Like give me the expected, get the chi-squared formula, do the degrees of freedom, look it up on the table. But number 7 is literally just give me these expected counts. So try those out. You can check in with me when you're done.